Hello students, welcome to session number 6 where we are going in module number 3 energy, solar energy in energy engineering subject where we are going to discuss about applications of solar energy in particularly solar thermal applications. The actual and proposed applications of solar energy may be considered in three important categories. Maybe one is direct thermal applications. Uh, second, then second one is photovoltaic methods, and third one is um, some other applications. Okay, like other forms of solar applications. But in a direct, as I explained in previous video, direct thermal application make a direct use of heat, which will result from the absorption of a solar radiation for space heating and cooling of residents and other buildings. So to provide hot water service for uh, such buildings, and to supply heat or agricultural, industrial, and other process that require only a moderate temperatures. Solar electric applications are those in which solar energy is converted directly or indirectly into electrical energy. There are four general conversion methods are being found in case of solar electric application. One is solar thermal methods involve production of high temperature such as they are required to boil water or other working fluid for operating the turbines, after generating steam, which will drive the electric generators, so that you can able to generate electricity. These are considered under solar thermal electric conversion. Okay, then second method is photovoltaic methods, which will make use of uh, uh, which will make use of solar cells to convert solar energy directly into electrical energy without any machinery. This will be discussed under solar photovoltaic conversion. And then third one is solar conversion or solar energy conversion into electrical energy without using the machinery, by utilizing thermoelectric effect is also considered, which is called as thermoelectric conversion. And the fourth one is wind energy, OTEC, and other form. Wind energy is the form of solar energy that can be converted into mechanical, which is like rotational energy, and hence into electrical energy by means of generator. So this is considered as indirect form of solar energy to generate electricity. Okay, then ocean thermal energy conversion depends on the temperature difference between solar heated surface and cold deep ocean water in order to operate vapor expansion turbine and electric generator. So this is also considered as indirect form of solar energy. Then energy from biomass and biogas refers to conversion into clean fuels or other energy which is related to product of organic matter derived directly or indirectly in the form of plants, or directly or indirectly from plants which use solar energy to grow. Okay, so biomass material include agricultural, forest, and animal residues, as well as terrestrial or aquatic plants. which is grown especially for the purpose. Okay. Then other forms of solar energy, water power, other than tidal power, also represents the utilization of solar energy. So it may be noted that since fossil fuels like coal, oil, and natural gas originate from living matter, their energy is really solar energy that has been converted and stored for millions of years. In fact, only nuclear energy and geothermal energy and large extent of tidal energy do not originate in the sun. Based on the based on the above classification, direct solar energy applications are discussed in this particular video, which is like solar water heating, solar space heating or cooling, solar energy which is thermal electric conversions, solar energy like photovoltaic electric conversion, solar distillation, solar pumping, solar refrigeration, agriculture and industrial process heat, solar furnace, solar cooking, solar pumping, etc. Next, we will see very first one, solar water heating. Uh, in that particularly natural circulation solar water heater, which is under pressurized. Solar water heating, in that the basic elements of solar water heater are flat plate collector, storage tank, circulation system and auxiliary heating system, and control of the that system. So the use of solar energy for heating water in many respects quite similar to use for heating buildings. There are, however, several aspects of solar water heating that make it a potentially better investment of energy in terms of energy as well as money and effort than solar building heating. For one thing, the demand for hot water is relatively constant throughout the year. Thus, the collector and other parts of the solar water heater will be uh, working harder and longer to produce the saving in fuel. Okay, so the simplest type of solar water heater is the thermosiphon system. Some typical and commercial designs of solar water heaters are: one is natural circulation solar water heater under pressurized, second one is natural circulation solar water heater non-pressurized, and forced circulation solar water heater. Okay, so we will discuss natural circulation solar water heater first. So this diagram shows about natural circulation water heater. A natural circulation system consists of a tilted collector which is facing south with transparent cover glasses, a separate highly insulated water storage tank, and well insulated pipes connecting the two. Okay, so connecting that to end. Okay, so the bottom of the tank is at least 1 feet or 3.0 meter, sorry, 1 feet, that means 0.3 meter, uh, 1 feet the top of the collector, and no axial auxiliary energy is required to circulate water through it. Okay, so circulation occurs through natural circulation or thermosiphoning. Okay, as the water is heated in its passage through the collector, its density decreases and hence it rises and flows into the top of the storage tank. uh, Colder water from the bottom of the tank has a higher density and so tends to sink and enter the lower heater of the collector for further heating. The density difference between the hot and cold water thus provides the driving force, which is called as convection, for the circulation of water through the collector and storage tank. Okay, Hot water is drawn off from the top of the tank as required and is replaced by cold water from the service system. As long as the sun shines, this water will quietly circulate, getting warmer and colder. After sunset, the thermosiphon system can reverse its flow direction and loss of heat to the environment during the night. To avoid reverse flow, the top of the heater of the absorber is kept as stated above, in the point 0.3 meter. Okay, below the cold leg fitting on the storage tank. I hope you can make out. To provide a heat during long cloudy periods and cloudy period, an electrical immersion or some auxiliary heater method can be used in order to make up backup for the solar system. Non-freezing fluid may be used in collector circuit. The thermosiphon system is one of the least expensive solar hot water system and should be used whenever possible. Thermosiphon solar water heaters are passive systems and which do not require any mechanical pump to circulate mechanical pump to any source like mechanical pump to circulate the water. Such heaters can be used extensively in rural areas where electricity is expensive or where electricity is not available and there is a little danger of freezing. So this is about solar non-circulation solar water heater, pressurized. Next we will see natural circulation solar heater, non-pressurized. Okay. So the sketch shows non-pressurized natural circulation solar water heater. In a pressurized system, which is able to supply hot water at locations of the storage tank. Okay, so this creates considerable stress on the water channels in the collector, which must be designed accordingly. The non-pressurized systems supply hot water by gravity flow only to users lower than the tank. If pressurized hot water is required for showers or appliances, the difference in height will have to be large enough to meet the requirements. Okay, so if the height of difference cannot be accommodated, then the only solution to install a separate pump and pressure tank. The stress within non-pressurized system are lower, which allows cheaper and easier construction. In this type, also a mechanical pump is not required. Uh, you can able to see that there is a only one way check valve you can able to see. Okay, so again auxiliary heater is can be given if it is to compensate solar energy during cloudy condition. Okay, then force circulation. This is about force circulation. You can able to see the next diagram where uh, including an electric pump in the return circuit between the bottom of the storage tank and the lower header of the collector. The tank can be placed at a more convenient level, maybe example, or like you can able to locate in basement of your house also. So this is now an active system because it is not passive. Pump is used, so pump will pressurizes or forces the flow. That's why it is an active system. And a control unit permits the pump to operate only when the temperature of the water at the bottom of the tank is below that of the water in the upper header. A check valve is needed to prevent reverse circulation and resultant nighttime thermal losses from the collector. In this example, auxiliary heater is shown, which is very much needed in order to compensate the uh, energy during cloudy condition. Okay. When there is a danger of freezing, the water may be drained from the collector. Alternatively, a slow reverse flow of the warmer water may be permitted through the collector during on cold nights. The freezing danger can overcome, although at some time it will increases the cost also by using an antifreeze solution as a heat transport medium. Okay. So this is about solar water heater. Here you can able to see post circulation solar water heater as I explained earlier. Okay. Space heating or solar heating of building. There are many concepts have been proposed and even tested for using solar energy in space heating of buildings. So there are two primary categories into which virtually all solar heating systems may be divided. The first is a passive system in which solar radiation is collected by some element of the structure itself or admitted directly into building through large south facing windows. That's about passive system. And second one is active system, in which generally which consists of separate solar collectors which may be either uh, water or air, and then it's having storage devices which can accumulate and collected energy for use at nights and during inclement days, and a backup system to provide heat for protected periods of a bad weather. Okay. So heat is transferred from the collectors or from the storage by means of conventional equipment such as a fan, fan coil units, or when hot or cold water is provided by fan ducts or air outlets. When the heat transfer medium is air, and radiant means when heating is the only task which must be accomplished, then it is called as active heating or active system. In passive system, which will operate without pumps, blowers, or any other mechanical devices, the air is circulated past a solar heated surface on the surface or and through the building by convection. uh, okay. So in active system, fans or pumps are used to circulate the air and often a separate heat absorbing fluid. First we will try to discuss about passive systems. Now, the passive solar thermal systems are more practical in locations where there is ample of winter sunshine and an unstructured or unobstructed southern exposure is possible. The building is to be which is to be heated is an essential part of the system design. Uh, but in active system, on the other hand, it can be adopted almost any location and any type of building. However, they are more expensive than passive systems to construct and operate. An advantage of active solar system is that the building air temperature can be controlled in the same way as with the conventional heating. Okay, so an increasing number of residents using various passive systems has been built and are under construction, mainly in US building, with the large window facing the equator, which is south in northern hemisphere and north in southern hemisphere, and arranged to admit solar radiation into the building. If a building is designed properly, it will function as a solar collector, collecting heat when the sun is shining and storing it for the later use. The building will function as solar storehouse. It must store heat for cool times when the sun is not shining, and store the cool for warm or hot periods when the sun is shining. So buildings which are made of heavy materials such as stone or concrete do this most effectively. Okay, so the basic design principles of passive solar space heating system, uh, that is without mechanical components, fall into the following five general categories. One is direct gain, second one is thermal storage wall, and third one is attached sun space, fourth one is roof storage, fifth one is convective loop. There are modification within each of these categories, and the two are more maybe combined in a single building. Okay, it is also possible. We will see what is direct gain. Direct gain Uh, in this system, the building has a south wall. I hope you can able to visual understand or visualize it. With the large number of windows, two layers of glass, which will minimizes the heat loss. Solar radiation entering the windows falls on thick concrete, slate or brick floors. Okay, brick floors, and is absorbed and stored as heat. Okay, so the building air is then heated by radiation and convection from the floor and walls, covering the windows with the shutters or curtains at night, which will reduces the heat loss. Whereas in thermal storage wall, a large wall like mass which absorbs solar radiation and store in it, which is placed directly behind the large south facing windows. The best known example of the storage wall design is vertical trombe wall made up of concrete brick or other masonry, some zero point 0.3 meter or more than that. Dr. Felix Trombe, who is the director of solar energy laboratory at France, has used this principle. The system is passive because the solar radiation is absorbed by a heavy concrete south-facing wall, which is covered with double glazing. Okay, so that is about thermal storage wall. Then attached sun space is nothing but any enclosed space such as a greenhouse or sun porch with a glass wall on the south side. A sun space may be attached to a thick south wall of the building to the heated by the sun. Vents near the top and bottom of the wall as is permit circulation through the main building of heated in the sun space. So heat storage is provided by the thick wall or a concrete or masonry floor. Okay. Then roof storage means you can able to see in this picture. It is a sorry sun space. You can able to see this in this picture. Okay. So the sun space is enclosed space such as a greenhouse or sun porch with a glass wall on the south side. The space may be attached or built on a thick wall of a building which is to be heated by the sun, and the vents near the top and bottom of the wall will permit the circulation through the main building of the heated sun space. Through density difference the air will move, and heat storage is provided by the thick wall or a concrete or a masonry floor, water containers and other materials in the sun space. Thus, an attached sun space system combines features of direct gain and storage wall concepts. Okay. Next is about roof storage solar heat. So you can able to see here a passive solar system. Trade named by Sky Thermal was designed for house having a flat roof located in a mild climate. The heat is absorbed and stored in water about 0.25 meter deep, which contain the plastic bags held in blackened steel boxes on the house roof that you can able to see. Uh, a layer of clear plastic, okay, to the top of the bag provides a stagnant airspace to reduce heat loss to the atmosphere. So heat is transferred from the heated water to the rooms below by conduction to metal ceiling. Air circulation may be aided by means of electric fans, but this is not essential always. Okay, and to prevent loss of heat during the night, thermal insulator panels are moved either manually or by time controlled electric motor to cover the water bags. In the daytime, these panels, which are in sections, are removed and stacked one above the other. Okay. Next is solar absorption air conditioning or refrigeration system by using solar energy. Two approaches have been to solar operation of absorption coolers. The first one is continuous cooler, which is in construction and operation, and which is similar to conventional vapor in construction as well as in operation. It is similar to conventional vapor absorption refrigeration system. The solar collector storage supplies the energy to the generator where solar energy is available, otherwise it is supplied with the auxiliary energy source. The second approach is which will use intermittent coolers, which are intermittent in operation and will operate during the periods when solar energy is available, and when it is not available it won't work. Okay. In particular, a solar energy is consists of generator, condenser, expansion valve, evaporator, absorber, liquid pump, and heat storage. So I hope if you know about the solar absorption, sorry, absorption refrigeration system, Only thing is here the energy required for heating the refrigerant is used as a solar energy. Okay, so the absorption air conditioning system is shown now schematically here. So it consists of two parts. One is the solar collector and storage part, and second one is absorption of air conditioner or auxiliary heating part. The operation of air conditioner or absorption system with the energy from flat plate collector and storage systems is the most common approach to the solar cooling today. In essence, cooling is accomplished as the generator of the absorption cooler is supplied with heat by fluid pumped from the collector storage system or from auxiliary. Okay. So heat is supplied to a solution of refrigerant in absorbent in the generator, where the refrigerant is distilled out of the absorbent fluid. The refrigerant is now liquid and is condensed and goes through a pressure reducing valve to the evaporator, where it operates and cools air or water for the cooling space. The refrigerant vapor goes to the absorber, where it comes in contact with the solution, which is weak in refrigerant and which flows from the generator. Okay. So the vapor absorbed in the solution, which is then returned to the generator. A heat exchanger is used for sensible heat recovery and greatly improves cooler COP. So from the point of view use of conventional energy source, there is a single index of performance for rating cooling process, that is COP. The ratio of the amount of cooling to the energy required is called as COP. Okay. So for solar operation there are two additional factors: the temperature required in the solar collector to drive the process, and the ratio of cooling produced to solar energy incident on the collector. So as solar process are inevitably transient in their operation, the energy ratios and temperatures will vary with the time, and COP is mainly based on long-term integrated performance provides an appropriate index performance. Okay, so the coolers used in most experiments today are lithium bromide water cooled absorber and condenser. The pressure in the condenser and generator is fixed largely by temperature drops across the heat transfer surfaces in the generator and condenser. Okay, so with this I hope you are able to, this is similar to the absorption system, but the only thing is to provide heat to the heat in heat exchanger, the solar energy is used. Next we will study about power generation cycles. So especially when it comes to solar thermal electric conversion, as I mentioned, it is only about thermal conversion. The conversion of solar energy into electricity by two-way, I already mentioned, thermal or thermal energy. Heat can be converted directly into electrical energy by solar cell or thermionic or thermo electric models. In solar thermal power generation, which employs power cycles which are broadly classified as low, medium and high temperature cycles. Low temperature cycles generally use flat plate collectors so that maximum temperatures are limited to about 100 degrees centigrade. Medium temperature cycles works at maximum temperature ranging from 150 to 300 degrees centigrade, while high temperature cycles work at temperatures above 300 degrees centigrade. This diagram is explains about low temperature power cycles. For the low and medium temperature ranges, the thermodynamic cycles preferred is the Rankine cycle. So, for a high temperature range, apart from Rankine cycle, Brayton cycle or Stirling cycle is also considered. Two basic arrangements have been proposed for converting solar radiation into electrical energy. One is a central receiver system, and the second one is distributed collector system. Okay, so in the central receiver system, commonly known as a power tower, design an array of sun tracking mirrors, heliostats, reflect solar radiation into a receiver which is mounted on top of a central tower. So solar energy absorbed in the central receiver is removed as heat by means of heat transport fluid and converted it into electrical energy. In a distributed type system, which may consist of a number of parabolic trough type or line focusing collectors, or a paraboloid dish type, which is point focusing collectors. These absorber pipes of the individual collectors are connected so that the heated fluid is carried to a single location where uh, the electricity is generated. Okay, the basic difference between the central receiver and the distributed collector system is that in the former, the solar energy falling on large area is transmitted to a central point as radiation, but in later the energy is carried as heat or fluid. So in figure shows there is a flat plate collectors and booster mirrors you can able to see. So solar radiation falls on a flat plate collector as well as booster mirror, which will concentrate solar radiation to flat plate. So the water, the pump which will pressurizes the water to flat plate collector, where it gets heated up, and the hot water is going to store in storage pump, and that water is utilized to produce vapor in heat exchanger, and the vapor which is generated almost about 90 degrees centigrade is utilized to run turbine by means of expansion, and the generator is coupled to the turbine so that you can produce or you can convert mechanical energy into electrical energy, and thereby you can able to generate electricity. So this system falls on low temperature power generation, especially based on the for thermal using solar thermal energy. Okay. Next, about solar chimney or power plant. So this is about you can able to see there is a large solar collector which is with a glassing arrangement. So solar radiation falls on to this so that it will trap solar energy, and it will hits the air which is surrounded in the solar collector. So it gets heated up, and air will move up. So in the way of tower, it's having a large tower, so that all airs are concentrated to one particular point, where air turbine with generator coupled air turbine is going to rotate, and it will produce electricity. So that is about solar chimney power plant. Next is about solar desalination. In that the purification of water, which can be made by using solar energy. Solar energy. So fresh water is very much necessary for for humankind, and also the key to man's prosperity. So it is generally observed that in some area, especially in coastal areas, where which are thinly populated and scattered, one or more family members are always busy in bringing fresh water from a long distance. Correct, no? So in these areas, solar energy is plentiful, and it can be used for converting saline water or into distilled water, or impure water into distilled water, which is pure water which can be able to drink, or cook, or any other purpose. The pure water can be obtained by distillation, or desalination in the simplest solar still, which is generally known as solar basin type solar still. So that is shown in diagram actually. So it is such solar stills have been operated for farm and commonly used in several countries. It consists of a blackened basin containing saline water at a shallow depth, over which at the top a transparent airtight cover that encloses completely the space above the basin. So it has a roof-like shape. The cover, which is usually glass or maybe plastic, which is sloped towards a collection trough, and the solar radiation passes through the cover and is absorbed and converted it into heat and in the black surface. So impure water in the basin, impure or salt water which is in basin, or tray is heated up, and the vapor produced is condensed to purified water on the cooler interior of the roof. Okay, so the transparent roof material mainly transmits nearly all radiation falling on it and absorbs very little. Hence, it remains cool enough to condense the water vapor. The condensed water cools down and sloping roof and is collected in troughs at the bottom. So saline water can be replaced in the operation by either continuous operation or batch by batch, that is batch production. Although there are numerous configuration of basin type units, their basic theory is identical. It uses the principle of rain. Okay, it will mimic that. Um, the basin type solar still has produced distilled water at a cost per unit of product lower than other types of solar equipment, and is the only one type in operation. So operating efficiency is about 35 to 50% for basin type still, but still have been achieved in practical units, and as compared with the theoretical maximum and slightly more than 60%. Okay, so the performance rating and efficiency of the solar steel is determined by plotting the graph of the amount of fresh water produced per unit of basin area in one day versus the solar radiation intensity over the same period. Such curves for several steels are drawn, and efficiency is defined. Efficiency is equal to W into delta H divided by H, where W is the weight of the distillate water, delta H is the enthalpy change, and H is solar radiation or solar intensity. Okay, you can able to design it. That is about solar desalination. Then solar distillation where or solar dryer, where you can able to use that solar energy in order to dry the fruits or vegetables, okay, as per our requirement. In rural areas, especially in our country, in rural areas, the farmers who grows some seeds, or especially the areca growers, they will use such type of dryer for drying their crops, okay. So where you can see there in that sketch, it is similar to that distillation uh, distillation method, but there you can see product on web various trays, and you can construct a wall where the small ventilation is provided in order to movement in order to move the air, and solar transparent cover is laid at the top, so solar radiation will falls onto it, so it will absorb the heat, and the crops will be, or the items which you are going to keep it inside, it will dry, okay. Then about next application is about solar cooker. So in our country, energy consumed for cooking shares as a major portion of the total energy consumed in a year. So in villages, 95% of the consumption goes only to cooking. So variety of fuel like coal, kerosene, cooking gas, firewood, or dung cakes. Okay, cakes and agricultural waste are used for cooking. The energy crisis is affecting everyone as well as every country. So it is affecting the fuel bills for those who use it for heating the houses and cooking their food. So the poor of the developing countries who have been using dry wood uh, picked up from the fields and forests, as well as from domestics fuel, have been affected and in their own way. So this the for this we can use solar energy for cooking. So the solar cookers have a very relevant place in the present fuel consumption pattern. So various designs of solar cookers have been developed in our country. The first solar cooker was developed in the year 1945 by Mr. M.K. Ghosh in Jamshedpur, who is a freedom fighter. Okay, and he developed a box type solar cooker with a reflecting mirror and copper coil inside, on which the food materials used to placed in pots. Mr. Ghosh also designed a parabolic reflector which was used for some time as a boiler in Nira means palm juice. Later, in 1953, NPL of India developed a parabolic solar cooker. The main resource, or the main reasons for non-acceptance of these devices was cheap availability of cooking fuel during these days. The problem of harnessing and utilization of solar energy arose after the fuel crisis in 1970s. Okay, so you can able to see in diagram a flat plate box type design, which is very simple of all the types of design. So maximum no load temperature with a single reflector reaches up to 160 degrees centigrade. In multi reflector woven, four square or triangular or rectangular reflectors are mounted on the woven body. Okay, they all affect in reflection of the solar radiation into the cooking zone in which cooking utensils are placed. The temperature obtained is in in the order of 200 degrees centigrade, and the maximum temperature can reach up to 250 degrees centigrade. If the compound cone reflector system is used, or with a parabolic dish concentrated, the solar cooker may get temperatures up to 450 degrees centigrade. Okay, so the design principle and construction and details of a box type solar cooker, which is shown in figure, is like the solar rays penetrate through the glass covers, as you can able to see a mirror, isn't it? So glass covers and absorbed by a blackened metal tray kept inside the solar box. So you can able to see a transparent cover and mirror, then guiding for adjusting mirror, insulated box, cooking pots and handle, isn't it? So the solar radiation entering the box are of short wavelength. The higher wavelength radiation is not able to pass through the glass cover, so that is re-radiation from absorber plate to outside the box is minimized by providing the glass cover. The two glass covers are provided to again minimize the heat loss. Thus, the loss due to convection is minimized by marking by the air, or by a box airtight by providing a rubber strip all around between the upper lid and the box. Some insulating material like glass wool or paddy husk or sawdust or any other material can be filled in order to minimize the heat loss. This minimizes heat loss due to conduction. With this type of cooker is placed in the sun, and the blackened surface starts absorbing sun rays and temperature inside the box starts rising. The cooking pots, which are also blackened, are placed inside the food material, get heat energy, and food will be cooked in a certain period of time depending upon the actual temperature it is inside. So in this way we can able